So we look mainly at the asymptotes, right? And the shape. If it was some transformation of 1 over x, it was the two arms. 1 over x squared was kind of like the speedo, or not the speedo, like a little, anyways, like that. And then we transform it. All right, now we're going to look at just a few more rational functions, and not necessarily in transformation form. So we want to get some of the features from that. So it says in question 1, state the equations of the horizontal and vertical asymptotes without using technology. So this is kind of a review of what we talked about yesterday. So vertical asymptotes, we look at the denominator, right? Just like if we were finding the non-permissible values of the restrictions. So here, 3x plus 4, remember, cannot be 0. So this is for your non-permissible values or restrictions. So that means x cannot be negative 4/3. So that means your vertical asymptote is x equals 4/3. So remember, for the equations of the asymptote, negative 4/3.
One question you're understanding the after.
Yeah, is negative 4/3. X equals negative 4/3, right? The vertical line. So you don't put the not equal to it. That's just if you're stating restrictions. Then for horizontal asymptotes, remember, same degree. So check the degree of the numerator and denominator. If they're the same degree, they are. So it's the ratio 5x over 3x, which is just the ratio of the coefficients, 5/3. So y equals 5/3. And that's all we're asked to do here. B, vertical asymptotes. What's up? Are there any? No. Right? X squared plus 4 will never equal 0 in real number system. So there are no vertical asymptotes. Right? Horizontal asymptotes, the numerator is degree 1, denominator is degree 2. So the denominator has a higher degree. So it's y equals 0. That denominator will get bigger faster than the numerator. So they approach a value of 0.
Okay, why is there no vertical asymptote?
There's no way, there's no value of x that will make that 0. Right? If you say that, well, then you'll have x squared can't be negative 4. Well, x squared will never be negative 4. You can never square a number against that. Maria? Say that again.
Wouldn't you have said, so remember yesterday how you said it doesn't, like, if there's a degree, you add, like, x equals plus 0 and plus 0.
Oh, you mean up here?
Yeah.
Yeah? Okay. And then that would be 0 over 1. Okay, next one. Can't factor the numerator, we can factor the denominator. Okay. So then, that's y equals. So your vertical asymptotes, don't forget about this x. So one of them is x equals 0. Another is x equals negative 4. Another is x equals 2. When you're stating vertical asymptotes, they are equations. So you don't say x equals 0, comma, negative 4, comma 2. Right? Those would be if you were stating non-permissible values. This is stating equations. So you have to list the easier to go back to the beginning form before we factor. They're both cubics, so the same degree. So 8 over 2 is 4. Okay, so that's kind of a review on asymptotes from yesterday. Not yesterday, so day before yesterday. All right, let's take a look at this one. So, predict the equation of the vertical asymptote. Nothing to factor there, it's already binomial, so that's going to be x equals 3. Get your graphing calculator out. GBC needs graphical display calculator.
Press enter for a second. I want to see what that value is.
I will. Okay, so if you have, listen please, if you have a newer calculator, you can do the fraction. Alpha equals enter, and you can make it look like a fraction. If you have an older version of the calculator, then you need brackets and you use division. Okay? So, know your calculator. Just do it on the standard screen. So why? Special features. It's a line. It sure is a line. Okay. So it says use a graphing calculator, sketch the graph plotted on the axis. Listen please. So find an y-intercept is -2. X-intercept looks like +2. Looks like a line. Okay. Okay. Why is the graph as you expected? Well, you might have expected because of the graph that we were doing yesterday that maybe it was curved, had arms, had an asymptote at x equals 3, something like that. Okay? So, in general, probably no. First of all, because of their asymptote, right? Okay, so let's simplify that rational equation. How do we simplify? We factor first. Okay, back to math 10. And you'll see that you have a common factor. So simplifying rationals back from last year, we divide out the common factor. And we get y equals x minus 2, which is the equation of a line. That's why it looks like a line. Okay. But what about x equals 3? X is 3, then that is undefined, right? So we have to be able to put every value of x in and get a value out so that we can graph it. We put 3 in, we can't, it doesn't work, right? So So this would be a yes. And then it gives you a hint here. You could change your window. Some of the new calculators you might be able to just, let me just see, this is really what we're doing. If you do zoom decimal, yeah, let's do zoom decimal, don't change it manually. Zoom decimal, you'll see, you might not be able to see at the back there, but do it on your calculator. You'll see a little gap. Okay? So that gap, if you look down, has an x value of 3. So really, I need to change this to here. Okay. So that's what it looks like on your calculator. Focus, you guys. How we draw it when you're graphing it, either I am for you or you are for me, is with an open circle there. Okay? So that means the graph gets really close to that point that doesn't touch it. So you can have, so this is 2, this would be 3 here. So you can have a point that has an x value of 2.9999999, but you can't have a point that has an x value of 30. Yep. Exactly. If it's got a numerator and denominator that are higher than degree 1 in factor, to see if there's a point of discontinuity. A common factor between the numerator and the denominator. Okay, so let's keep going because we really should find the y value at that point. Okay, so we did zoom decimal. So you should have noticed that the graph is exactly the same as y equals x minus 2, except there's a hole at the point. Okay, so this is where we know it's 3 for x. How do we get y? If I put 3 back into the beginning, I get undefined, right? So I can't put it back into the original to get the y value. Because I'd be dividing by 0. I want to put it back into the simplified form. So when x is 3, y is 1. Okay, so the coordinates of this point here are 3 and 1. Okay, so substitute x equals 3 into simplified equation. Okay, so the graph is not continuous at that point, and so what we call it is a point of discontinuity. Discontinuity. Okay, so we already adjusted our graph. I put the little round open circle, and you know that back from graphing on number lines, right? Back from junior high. Okay, you do the open circle, and we reviewed it last year too, right? Open circle means does not include that value, but that's really close. Okay? Quiet, please. The x-coordinate of the point of discontinuity is the non-permissible value of the original function. Substitute this x-coordinate into your answer to question 2D. Did you get the corresponding y-coordinate of the point? Yeah, because that's how you do it. How do you do it? so next part. All right, so the next says use your calculator to sketch. There's two functions here, so same thing. So basically, we're trying to sort of discover some things without, so here, we're just going to graph it in our calculator, and then we've got to learn some things already, and we're going to confirm it algebraically on the right-hand side of the chart. We're going to go back to standard screen just to make it as possible. Okay, so may not have been what you expected because there's two non-permissible values in that. I only see one asymptote. So now that we've learned maybe there's points of discontinuity, we'll have to figure that out. So you're doing a sketch. You can tell there that the x-intercept is -1. You can tell that the vertical asymptote is x equals -2. Horizontal asymptote looks like it's at 1, which makes sense from our previous asymptote knowledge. Remember, this is just, we're just doing a sketch here. Okay, so, equation of this vertical asymptote is actually only 1. Even though we think that there's 2, there's only 1 vertical asymptote. So, factor it and see why there's only 1. Factor the numerator and denominator. It just says the vertical asymptote. It doesn't say horizontal. So, from that, x minus 2 divides out. The non-permissible values, remember, so NPVs are 2 and -2. That gives us, the -2 gives us a vertical asymptote. The +2 gives us a point of discontinuity. So if we look closer here, and if I go trace and punch in x equals 2, notice how nothing shows up. That means it's not defined yet. There's a gap. Okay, if you want to do your zoom decimal, it tends to show up a little, that gap shows up there at x equals 2. Okay. So I need to take my eraser and just erase a little bit. Put an open circle there. Okay. Remember this x-intercept was -1. This point here is going to be 2. How did I get the y value? I put x equals 2 into this simplified form. So 2 plus 1 is 3. 2 plus 2 is 4. So that's going to be 3/4. So point of discontinuity at 2 3/4.
Okay.
Yes.
Why wouldn't it have like 2 vertical asymptotes, one like negative?
Because this divides out here. If there's a common factor between numerator and denominator, then it's not an asymptote. It's a point of discontinuity. So we factor everything. If nothing divides out, that's going to be a vertical asymptote. If it divides out, it's a point of discontinuity. Basically, if this graph is that, with a restriction, exactly, but this is how you build it. Someone decided, oh, I'm going to multiply top and bottom by x minus 2, right? And so that creates a point of discontinuity. It doesn't change the graph, because anytime you multiply by equivalent of 1, it doesn't change anything. But it introduces a restriction.
Sorry, in the previous question where you can predict the equation of the vertical asymptote, there was ever accurate.
You're predicting based on what you did know, but it turned out not. All right, try the next one. Notice how it has the same denominator as the last one. Okay, so it says to use your calculator. You don't have to know how to graph it without a calculator. Okay, so this one looks like it does have 2 asymptotes. I'm getting into a fight with it. Okay, so based on that, looks like it's at positive or negative 2, which kind of makes sense. Okay. Looks like it has an x-intercept of -1 again. Looks like it has a horizontal asymptote at y=1 again. Notice that, so be careful. Some students say, well, if it's got an asymptote, it can't cross an asymptote. True definition of an asymptote is that what line does the graph approach when x gets really big, so approaches infinity, or negative infinity. So we don't really care what happens around the y-axis. So this graph actually goes through the asymptote. Okay, so it's going to look something like this. But this graph here, actually you can
Can you ask us to like draw something like this by hand,
Yes. Just too small.
Oh, this one, it would just be a sketch. We wouldn't ask for, we'd only ask for any x or y intercept.
Yeah, because I'm trying to think like, you could do the asymptote, but you couldn't, do the thing where you oh no, it
Okay. Listening, please.
But you can figure out stretches.
Yeah, no, but we would, yeah. So just be aware that you can have something that goes through. A lot of times you say, oh, well, that's not an asymptote. Around here, it doesn't matter. That's around x equals 0. Right? Asymptote is when x gets really big. Far that way or far this way. That's what they're opposed to. Okay? In any case, the asymptotes are x equals 2 and x equals -2. If we factor this one, you'll notice that nothing divides out. Okay? So if the factors in the denominator do not divide out, that will be what gives you your vertical asymptotes. If they divide out, then whatever divides out tells you that's a non-permissible value, and that tells you what your point of discontinuity is. Okay, so always factor first to help you in sketching this. So there aren't any points of discontinuity in that one. So we've kind of done some of that work down here. It says, although both of the functions have the same two non-permissible values, one of the functions has two vertical asymptotes. The first one has only one vertical asymptote and one point of discontinuity. Use the factored form of the equations to explain how to determine whether there will be an asymptote or a point of discontinuity. So I kind of set it vertically, but at any given non-permissible value. So if a non-permissible value, oh. How do you say that properly? So the non-permissible value forms a factor in the numerator as well as the denominator. So basically repeated. Then there will be a point of discontinuity at that value. Okay, so at that non-permissible value. So the first one, the non-permissible value is 2 that formed a common factor between the numerator and denominator. And so there's a point of discontinuity at x equals 2. Does that make sense? And if it's not repeated, then it's just a vertical. Right? So if I'll do the other part. If a non-permissible value forms a factor only in the denominator, okay. Okay, so turn over to the next page. Okay. Notice either that's the last page in the booklet. Monday we'll just do on our own paper. Okay? We'll just be solving rationals, which is kind of review for you guys. Oh, you need it?
Yeah.
Okay, so take a look at this. No factor needed in the denominator, but maybe there's a common factor. We don't know yet. First thing, it's asked the non-permissible value is this -1, right? If you're just asked for the non-permissible value, you just take the number. Will there be a vertical asymptote or a point of discontinuity? Justify your answer. So how are you going to know? You have to factor that numerator. See if there's a common factor. Well, it was you every other time. It was your friend John? You're gonna blame you, yeah. Now you know what the real friendship is, right?
Yes.
I'm not trying to drive you apart. I'm trying to make you be cool.
I'm gonna teach you math.
Okay, so it does have a common factor. Simplify it. That's the equation of the line that you can draw. You don't need a calculator. Better know how to graph or sketch that line. That was math 10. Okay, so phi, y-intercept, slope of 2, so you're guessing a little bit here, but it was about here is your x-intercept. I guess I can put that down here, right? Okay, so x can't be -1. Now we want to put in -1 for x. Okay, so that's going to be -2 plus 5 is 3. So our point is going to be -1, 3. So now, -1 would be about there. So open circle. So if you have a ruler, it's something you want to circle. Okay, then label that negative, -1 and okay. Okay, x-intercept, I plotted it already, is -5/2. You can always find that no matter what, however many factors you have up here. You did this yesterday, or Wednesday, remember. You find that from the numerator, right? Anything that's not divided out, so really clear. X-intercept is when y is 0, solve for x, so -5/2. And the y-intercept is just 5, right, when x is 0. So I kind of sketched it before filling those things in, but you could have filled them in the basket. now we get to a little bit harder one. Degree 2 in the numerator and in the denominator. So it says the equation of the horizontal asymptote. It doesn't say plural, so probably there's only one, but you might want to go to part B first before you answer that. So factor form and then simplify that. So the asymptote is at x equals -1. The non-permissible values are -1 and +3. Oh, it does say horizontal. Right. We didn't have to do the other work first. That makes sense. So horizontal will be y equals 1. Thank you.
That's only keep it. You got one wrong. First of all, that question was the answer too, so it's still. That question's on 2, not on 1. Hopefully.
Okay, so I should have put in that I needed to do this work before answering that, right? Found my mistake. In any case, now we're down here. So at the non-permissible value of x equals -1, there is a vertical asymptote, right? But that did not divide out. So there is a vertical asymptote as x approaches -1. What happens? So as x approaches -1, the y value, so basically in either direction, we don't care if it's approaching positive infinity or negative infinity, this is the absolute value of it. So this we just put infinity, because we're taking the absolute value of y, right? Next year, or next semester, I guess, in calculus, you'll be doing a lot more stuff with really what we're doing is taking the limit and you'll look more closely. You have to say positive infinity and negative infinity in different statements. So that would be this part, right? So as x approaches -1 from the right side of the vertical asymptote, y approaches what? Okay, listen please. So think about it. If you have a graph, you can look at it. We don't have the graph. So if we're approaching here, so -1 from the right side of the vertical asymptote. So we've got here, here's an asymptote of -1. From the right side, that would be an x value of like -0.99 or -0.9. Think about if you put that value in here. -0.9 plus 1, would that be positive or negative? Positive, and this would be positive, right? Because y really overtakes it. So that's going to give you positive infinity. As you approach -1 from the left, that would be a value like -1.1. So -1.1 plus 1, is that a positive or negative? Negative. Small negative, this would be still be positive. So that's going to be a big number over a small negative would be negative infinity. Okay? Again, we're kind of going into detail here. We're not going to go into a huge amount of terms of testing you on that. But next semester in calculus, you'll do a lot more. At x equals 3, there is a point of discontinuity. Okay, so the x value is 3. You need to put it for 3 in here. So 3 plus 5 is 8 over 4. So the y value is 2. Okay. X-intercept. So we want to take a look. We only care about the other factor that's left here. X-intercept is when y is 0. So that x-intercept is going to be negative 5. Y-intercept is when x is 0. So really it's the ratio of the constant terms. So it's positive 5.
Yeah, just like, since it's not like big. Yes, that's not good. No. Yeah, it's the ratio of the constant terms because x is 0.
Yeah.
When we do the ratios with like the structure, that's where we're turning the horizontal asymptote.
Okay, so now we're going to sketch it and then verify. So think about your asymptotes. Okay, so asymptote is at negative 1. Then, what else do we know? We know x-intercept at negative 5, y-intercept at positive 5. Horizontal asymptote was the first one at y equals 1. Now, you might think, okay, what do I do now? Is it going to be the 2 arms? Well, it is a linear over a linear, right? Degree 1 over degree 1. It's not in transformation form, but we did some converting of those to transformation form, and we always got the 2 arms. So in this case, if you just wanted to do a sketch, which is what it is, then we would make sure to label, I forgot to do that on this, label your asymptotes, label your intercepts. You're obviously going to have to P2 would be somewhere around here, your point of discontinuity. And then we know that as x approaches negative 1 from the right, it's going to positive infinity. And from the left, it's going to negative infinity. So it's going to look something like that. If we had to get more exact points, obviously we can substitute points in. You can also, remember what we did the other day, is x plus 5 over x plus 1. We could divide to get it into transformation form. So that would be a 1. So y equals x plus 5 over x plus 1 is the same as 1 plus 4 over x plus 1. And if we rearrange that, then you could take our 1 over x, stretch it by 4, move it left 1 and up 1. Right? If you wanted to have some more points. We weren't asked for that, but we wouldn't actually even ask specifically those points, but that's what you can do. Okay, let's check it with our calculator. So I would go back and put the original in, so then you can check your point of discontinuity. If you don't, then you're not going to see your point of discontinuity. Okay, so I can't see my point of discontinuity in this. I can do my decimal. Let's see. Okay, I should label that 3, 2. Okay. But if you wanted some more exact points in between, then you could use the transformation step. So domain, all values of x, where x cannot equal negative 1 and 3. And range, all values. So be careful on the range. It's not just y cannot equal 1. Because there's that point of discontinuity. So y cannot equal 1, and it cannot equal 2 as well. I've actually been doing a bit about that.
How would you write that?
You have to do
Like
negative infinity to 1, 1 to 2, 2 to infinity from brackets.
It's still, I still find it faster. Just because I don't have to do speaking fragments. Which, they don't take up that much time.
Okay, so, okay, so we're kind of running out of time. We're going to skip to question 7. Okay? And if we have time, we'll go back to the chart and question 6. But for sure, question 7, because that's given a graph. That's given a graph coming up with an equation, which is more likely, a more common question you'll see on a test or the final exam. Okay, so number 7 is what we're going to skip to. So it says, write the equation of the rational function shown to the right. It says in simplified form, but we're going to actually say in factored form. Okay. So take a look closely at it. There's obviously, I would try to figure out where the asymptotes are. So with your pencil, find halfway in between those arms. Halfway horizontally between those arms. Okay, so I look for asymptotes. Look for points of discontinuity. Look for x-intercepts for sure. Maybe y-intercepts in terms of checking. So here, 3.5. When we show anything in factored form, we never use decimals. So this 3.5, what is that as a fraction? So what is it as a fraction? Let's go back a few years of time. 7 over 2. Okay. So what can we fill in? It's a rational. I've got y equals the fraction. So vertical asymptote at x equals 2. So I've got to have an x minus 2 there. Okay. Point of discontinuity at x equals negative 1. So that point is negative 1, right? So I've got to have x plus 1 and x plus 1. I just actually put them vertically above each other, below, because I have to have those in order to have a point of discontinuity. What do you think? What else do I need? What would go here? Numbers, factor, x-intercept towards the factor, exactly. So this would be 2x minus 7. Okay. Not quite. Okay, so the last thing is, so those are the factors. That's good. We could have another number out here. Okay, so what is the horizontal asymptote here? 2. What's A going to be then?
1.
1. So in this case, we didn't need it, right? Because when I expand this out, I'll get 2x squared over 1x squared. Okay. Oh, yeah, true. Haven't quite finished. So, 2 is the stretch factor, right? That gets our right, because it's opening the other way, right? So, what do we have to do? So it needs to be, okay, so if you're not sure, let's actually choose a point and figure out what it is. Yeah. What you would do is go to your Simplified, not with the x plus 1's, right? You can actually use the point of discontinuity as well. Yeah, so, anyway, let's figure it out here. So you could use a nice point, so 1, 5, you could use the point of discontinuity. Is there another, maybe, oh no, that's not, 5, 1 might be used. So,
oh, it's because these are like, they're basically like, inverses of, yeah, because that's reflected about the, not inverse, right, reflected about,
yeah, so here, this is going to be, yeah, this is, yeah, you don't need, it doesn't need to be negative, but, so, we'll talk about that. Okay, so we get 5 equals 5a, so a equals 1. So it is 1. Reason why, it's always good to check, we didn't need to check. What our reasoning for thinking it might be negative is if it's in transformation form, then it would be negative, right? So this is not in transformation form, so you didn't have to worry about a negative in the a. Okay, kind of a different a. This is a factor, constant factor. It's not the direct factor.
that's an A.
It's
A prime, what does it mean?
K, you can call it K. It's just a factor of front. Okay, so in any case, now this would be, so we can just leave it like this. That's in factored form. An alternate to that you could write, although if it's on a diploma exam, you ask for factored form, I would actually leave it like that, at least show both ways. Or, this is the only alternative. You could say y equals 2x minus 7 over x minus 2, where x is not equal to both of those. So really we should have here, obviously, x cannot equal negative 1 and 2. Here, negative 1 and 2. If you showed me this and forgot to include the negative 1, then for sure you wouldn't have the correct function. Because if I graph this, I will get that graph going all the way through that point. I think about using your calculator. If I graph this, I'm going to get that, but it will be continuous through that point. If I want the equation of that, this will do it, or this with that restriction C. Okay. You see the difference between those? Okay, think about how you would graph it on your calculator, what would you see? You graph just that, and you didn't make a statement about that, that would be continuous all the way through. The whole point is that you know how to find those points of discontinuity. Okay. So, wanted to make sure, because this is a common type of question that you might see on a test. Okay. Okay, we're going to go back to fill in the items that we didn't do on the way through. We went to skip to the end there for a sec. So back to the chart. If a rational function has non-permissible values, then in each non-permissible value, there will be a vertical asymptote or a point of discontinuity. Okay, so then what form of the equation will indicate? You need to put it in factored form. So the value of x that makes both the numerator and denominator equal to 0 corresponds to a point of discontinuity. The value of x that makes only the denominator, so that's the non-permissible value, right? But if it's only the denominator, making it 0, then that corresponds to a vertical asymptote. And the value of x that makes only the numerator equal to 0 corresponds to an x-intercept. Okay, then question 6. For the function given, state the equation of the horizontal asymptote. So, numerator and denominator both degree 2. 4 over 6 reduces to 2 over 3. Determine the equations of the vertical asymptotes, point of discontinuity, and x-intercepts. So we want to factor. So that's going to be 2x plus 1 times 2x minus 1. What's that? Negative 42 and 6. 42 and then that's 7, 14 and 3. Right, so then those divide out, reduces to this. Okay, so x into x cannot equal 1/2 or negative 7 over 3. So equations of the vertical asymptotes, that's going to be x equals negative 7 over 3. So vertical asymptote. Point of discontinuity. So point of discontinuity. So that's going to be 1/2 for x. Now we have to go back and put 1/2 in to our simplified. I'm going to do it up here. So what is that simplified? 1 plus 1, 3 over 2 plus 7. So 2 over 14, 17 over 2, so that's 4 over 17. Just going to check and make sure I get that. So we can always check. So what do we have? 2 bracket 1/2 plus 1. And 3 bracket 1/2 plus 7. Now, and then x-intercept, look at the numerator. That's going to be negative 1/2. Okay, so we didn't have to graph that one, we just had to find those properties. And that's it. We already finished number 7. I think that was, oh, there was a number 8, right? Write the factored form of the equation of a rational function with a vertical asymptote of 1/2, x-intercept, point of discontinuity. So, y equals vertical asymptote, so that's going to be 2x minus 1. X-intercept would be 4x plus 3. Point of discontinuity would be x minus 3, top and bottom. Okay, could be, I called it A before, and then Sue's got confused with the stretch factor. Let's just call it K. So we want to check. So if we simplify that, we want to now put in, I'll do it like this. So I want to check with 318. So 18 equals 4 times 3, 1. So what's that? 12 plus 3 is 15k over 5. So that's going to be 3k. So k equals 6. So now go back. It says write the factored form of the equation. So y equals 6, bracket 4, x plus 3, x minus 3, over 2x minus 1, x minus 3. Okay, alternatively, you can write it as 6 times 4x plus 3 over 2x minus 1, where x is not equal 1/2 and 3. We should really state that there as well. But if you don't have the 3 with this version, then it's wrong, right? Because this would actually graph every point. You wouldn't have a point of discontinuity, and you need to make sure you have it in there. So that's why we usually keep it in the factored form. On the diploma exam, this is what they're looking for. Okay, I think now we're done.